Namaskar. Today I am going to start the very first lesson of class 10. The first lesson is force, but in this chapter we will basically deal with the gravitational force. So I want to say this chapter as gravitational force or gravitation. Dear student, I hope you may have asked question yourself about the natural phenomena such as why planets revolve around the sun, why a stone thrown upward returns back, why an apple falls towards the surface of the earth, why an apple does not go away or upward. In this chapter, we are going to explore the science behind such natural phenomena. To understand this, first of all, try to know the history. Before 1542 AD, people used to believe that Earth is at the center and the other planets as well as the Sun are revolving around the Earth. Nowadays also some people may think that Earth is at the center or the Sun is revolving around the Earth. Simple, very simple. Some people may think that Sun is revolving around the Earth. This concept was even the scientific community used to believe this concept before 1542 AD. That concept is called geocentric concept. Geo means earth, centric means center. Earth is at the center. That type of concept is called geocentric concept, geocentric idea. In 1542 AD, Nicholas Copernicus put forward a revolutionary idea about the solar system. He proposed heliocentric concept of the solar system. Heliocentric concept means sun is at the center and the planets are revolving around the sun. This concept was proposed by Nicholas Copernicus. Is Nicholas Copernicus in 1542 AD. Later, by observing through a telescope, who discovered telescope himself, Galileo Galilei observed the satellites of the Jupiter, planet Jupiter, and he observed that satellites were revolving around the Jupiter. So he supported the idea of Copernicus. Very interesting. Whenever the Galileo Galilei proposed this idea or supported the Copernicus idea, he was convicted of heresy and was put under the house arrest for the last 7 years of his life. घरमै उसलाई चाहिँ बन्दगी बनाएर राख्यो 7 वर्षसम्म. किन? He supported the Copernicus idea because people used to think that Earth is at the center and planets are revolving or even sun is revolving around the earth. त्यो कन्सेप्ट भइरहेको बेलामा that uh, Galileo Galilei supported the Copernicus idea, so he was imprisoned himself in his own home. Later, Newton started to study about the solar system and the reason of revolving planets around the sun. Finally, Newton propounded a famous law of gravitation in 1687 AD. Now, let's, let's go to our point, gravitation. What is gravitation then? Gravitation is the mutual force of attraction between any two objects in this universe. Gravitation is the mutual force of attraction between any two objects. In this universe, every object attracts each other by a force. That force is called gravitation or gravitational force. Now, let us learn the Newton's universal law of gravitation. Newton's universal law of gravitation says that the gravitational force between any two objects is directly proportional to the product of their masses and inversely proportional to the square of distance of separation from their center. It means gravitational force F is directly proportional to product of masses m1 cross m2. Let us consider two objects. This is one object Let's the name of this object is A, and this is the another object. This is object B, and if A and B are separated by the distance d, then the gravitational force between them is directly proportional to the product of their masses and inversely proportional to the square of distance of from their square of distance of separation from their centers, means f proportional to 1 by d square. 1 by refers to inverse relationship. It means gravitational force increases if distance decreases. If gravitational force decreases if distance increases. Means if distance decreases, what happens? This increases. But in this case, what happens? If product of masses increases, what happens? This force also increases. Combining these two equation 1 and 2, we'll get F proportional to m1 dot m2 or m1 cross m2 by d square, or or we can write F is equal to g m1 m2 by d square. To remove this proportionality constant, to remove this is the proportionality sign, to remove this proportionality constant or to convert this proportionality constant into equality, we have to keep one constant here. This constant is called universal gravitational constant. What is this called? Universal gravitational constant, and the value of universal gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kg square. This value, the value of gravitational constant, was calculated by Henry Cavendish by using torsion balance. Okay, are you clear about gravitation, Newton's universal law of gravitation? The statement is the gravitational force between two objects is directly proportional to product of their masses and inversely proportional to square of distance of separation from their centers. And the relation given by the Newton's universal law of gravitation is F is equal to g m1 m2 upon d square. Now, evidences of gravitational force or consequences. What are the evidences, or what are the points we can say that there exists the gravitational force? Without any evidences, we can say there exists something. There should be evidence. The evidences are existence of solar system. Solar system exists there. Planets are revolving around the sun. Satellites are revolving around the planets. These are the evidences of the gravitational force. Otherwise, they would escape out from the solar system. Occurrence of maximum sea tide on new moon day and full moon day. There is the maximum sea tide during new moon day and full moon day. That also supports the idea of that also supports the gravitational force, because uh, maximum sea tide occurs due to the gravitational force between the sun and the moon. So on the new moon day and on the full moon day, maximum sea tide occurs. Existence of the atmosphere on the earth, that is also the evidence of gravitational force. An object fall due to gravity of the planet. Now, what is gravitational constant g? Gravitational constant, first of all, let us write the relation. We know that gravitational force F is equal to g m1 m2 upon d square. Okay, F is equal to g m1 m2 by d square. If you keep this, m1 is 1 kg, m1 is 1 kg. Okay, if you keep m1 1 kg, m2 also 1 kg, and distance of separation d is also 1 meter. What will you get? You will get F is equal to g. You will get F is equal to g. Therefore, g can be defined in terms of F, but you have to keep the condition. Therefore, gravitational force defined as gravitational constant is defined as the force between two unit masses separated by unit distance. Okay, gravitational constant, universal gravitational constant, is defined as the force between two unit masses separated by unit distance. Now, why Newton's law of gravitation is called universal law? Why the law is called universal law, gravitational law? It is because the law is applicable for every object in this universe. जुनसुकै objectलाई पनि applicable भएको हुनाले it is called universal law. Why gravitational constant is called universal gravitational constant? It is called universal gravitational constant because its value remains same everywhere in this universe. Remains same everywhere. Japan is same runs. It is not like acceleration due to gravity. It remains same everywhere. Means it remains 6.6767 into 10 to the power minus 11 Newton meter square per kg square everywhere. In moon also, in Jupiter also, in Mars also, everywhere. So it is called universal gravitational constant. Now, what is gravity? To understand the term gravity, first of all, once again take let us consider the case of gravitation. In case of gravitation, suppose this is one object, this is another object. If they are attracting each other by a force, that force is called gravitational force. But if this is big object and this is the another small object, this object attracts this object by more force than this object attracts by this object. So the gravity of a planet, suppose this is the planet, gravity of a planet is defined as the force of attraction of the planet to any object nearby it towards the center. Suppose the force between the sun and the earth can be taken as the gravitational force. But the force by the earth to an apple is gravity. That's why gravity is the special case of gravitation. Now, what is the effect of gravity on a freely falling object? Suppose an object is falling towards the planet. What is the effect? What is the effect of gravity? Gravity causes the acceleration on the object, and that acceleration is called acceleration due to gravity. That's why acceleration produced on a freely falling object due to gravity is called acceleration due to gravity. The value of acceleration due to gravity depends upon masses of the planet and radius of the planet. In case of the Earth, the value of acceleration due to gravity is 9.8 meter per second square on the surface of the Earth. On the surface, the value is 9.8 meter per second square. Today, I want to stop here and I will meet you in next class. Thank you.